Before going ahead, let me give you the overview of this whole unit, that what exactly we are going to do in this unit. So unit 1, as you share, it is something which is representing motion in one dimension.
Okay.
So motion in one dimension means whenever particle is moving along one specific axis. Like one specific axis means, so as we know that in the coordinate system, specifically we have three axes. This is something we can call X, this is something we can call Y, this is something we can call Z. So whenever
Mm-hmm.
the particle is performing motion along one particular axis, that thing comes under motion in one dimension. Now, this is something which is categorized into two different types. The first is motion along x-axis. Specifically, it is called rectilinear motion. You must have heard this term in the class. And sometimes we also call it translatory motion or translational motion. So whenever a particle is performing or doing motion along one specific axis, and that is something we can say x-axis. So the motion is known as rectilinear motion or translational motion. Whereas whenever particle is performing motion under vertical axis, so you can consider y-axis sometimes as a vertical axis, or specifically it is always z-axis. So that is something we call motion under gravity. This motion under gravity is something which is representing vertical axis. So whenever we are going to talk about motion along one specific axis, it is comes under this first unit, that is motion in one dimension. So here we are going to learn about so many different physical quantities, and these involves, we are going to learn specifically about, it starts with distance and displacement. You must have seen it in the classes.
Yes.
Then we're going to talk about speed and velocity. So this speed and velocity itself is of so many types. We'll be talking about average speed as well as average velocity. We are also going to talk about instantaneous speed. And to be specifically, we're going to talk about instantaneous velocity only. Once we are done with these quantities, we're going to talk about acceleration. So we'll describe each and every term, or we'll learn each and every term in detail. And later on, we are going to talk about graphs relating all these quantities with time. So that is again an important aspect of this whole unit. So
Mm-hmm.
before going into these terms or understanding what these physical quantities are, we need to understand how these physical quantities can be categorized. So any physical quantity which we are going to use in physics, they can be categorized into two categories. This is kind of very important, and this is kind of, you can say, a base. If your base is strong, it will be easier for you to do this. Scalars and vectors. First, I'll give you the outline that how scalars and vectors differ, and later on, we'll talk about the following phenomena, or you can say the operations which actually helps them to solve. So let's start with scalars. So scalars are something, or you can say that those quantities which has only magnitude.
Mm-hmm.
So which contains only Magnitude. Magnitude is something, or basically you can say a constant number to represent the quantity. For example, let's say we have 1 kgs of sugar. So this is something which is representing mass, I can say.
Mm-hmm.
Mass is one such physical quantity. Similarly, we can say a particle is moving with 2 meters per second of speed. So again, 2 meters per second of speed means it is representing speed. Speed is again a different physical quantity. Here, the most important point is that when we are solving or when we are talking about scalars, they can be easily solved using basic mathematical operations. They can be solved, or we can say operated with basic mathematical operations. And what these basic mathematical operations are: addition, subtraction, multiplication, what we have learned so far till this grade. Remember this thing that when we are doing these basic mathematical operations, they can be only used for scalars. We cannot use them for vectors. If we are going to use the same for vectors, the answers, or you can say, things will not work as they should. Now let's try
Okay.
to define what vectors are. So these are the very basic things, scalars if I'm talking about. If I give you some examples of scalars, okay, just tell me one more thing. Have you learned physics in any previous grade?
No.
All right. I'll give you some examples also. When it comes to scalars, so we have following examples like energy is one such scalar quantity. We talk about work. Here, work in physics is completely different what we used to understand in real life. Similarly, we talk about power, that is again scalar quantity. We talk about distance, that is again scalar quantity. We talk about speed and so on. We have so many scalar physical quantities. But more than that, we have so many vector physical quantities. And in physics, almost you can say 60 to 70% of physical quantities which we are going to learn here in class 11th is going to be vectors. And
Okay.
in order to understand physics or to solve numericals to a greater extent, we need to have a great knowledge of vector. If we have that knowledge of vector, we can easily solve it or easily deal with it. Otherwise, no, it will be a little difficult. So vectors. So vectors are something which has magnitude as well as direction. So we'll learn about it, that what exactly its direction is and how we can actually calculate it. So first of all, let us define it. So those physical quantities which has direction along with magnitude. So that is important.
Mm-hmm.
Now, how direction can be explained? So in order to represent direction, we have two ways. One, we can use angle to define the direction. Now, angle is something which is being measured from origin in the Cartesian plane always. And similarly, for representing direction, You can also use north, south, east, and west. So these are the basic directions which we have seen so far in our previous grades. So we'll be using these two things to represent the direction of any physical quantity which is vector in nature. So let us try to understand how we actually represent direction to a greater extent, and we'll also talk about what are the practical applications of vectors, that why we are actually studying it. So suppose I'm giving you a very basic example in order to understand what vector is. Suppose initially you are standing or you are there at a certain point, and the certain point must have some coordinate in the reference to the coordinate system. So I'll be assuming that coordinates are going to be like that. This is one such axis, this is another axis. So I'm assuming the particle or a particular person is standing at certain point A, and that point has a coordinate x, comma, y, comma, z. Okay, just tell me one more thing. Have you learned maths in previous grades? Like, what are the topics you have seen so far in previous grades related to maths?
I mean, there's a lot, but yeah, I know I'm familiar with these coordinate planes. And
Okay,
do you want anything specific or what?
okay. Have you started calculus yet?
I'm doing calculus AB right now.
Okay. What you have learned so far in that unit?
We did limits. We did area under the curve. Now we're on limits.
Okay, so soon you will be going to learn about derivatives and antiderivatives. So that is an important aspect to solve various equations here in physics. So make sure you learn it very specifically.
Okay.
All right. So I have assumed that initially the particle is supposed to be at this point. So this is something which can be represented by writing initial position, I can say. So this is something, the initial position of the particle. So in order to represent this initial position or any position of any particle, we use vector. So this initial position, it can be represented by a vector, and that vector is something we can represent like by. So I'm assuming this is origin, and this origin, from origin to this point A, whatever line I draw like this. So this line is something which is going to represent this vector,
Okay.
and this vector is represented by OA. One more thing we need to talk about vectors is that vectors is something which is represented by an arrowhead. That is an important point. Like for example, suppose I'm writing any vector, so that vector can be represented by, let's say, this A vector, B vector, C vector, and any other vector which is possible. So what we need to understand here is how this point is specific in context to the coordinate system. This point is specific in context to the coordinate system in such a way that these coordinates x, y, z must be specific. Also, this line which we have drawn in the name of vector, it must make some specific angle, theta. So
Yeah.
this OA will be representing the magnitude of the vector, and this theta is going to represent the direction of the vector. We need to understand this thing to a greater extent because this is very basic, this is very important. So whenever I'm talking about a vector OA, let's say, so it is represented by an arrowhead over it. So as we know, this vector must contain two things. The one, it should contain magnitude, and another, it should contain direction. These two things combine will make a vector. So how the magnitude of a given vector is being represented or written? It is represented by modulus. Do you know what is modulus?
Modulus. Yeah, I forgot. I knew though.
All right, we'll see it soon.
Okay. So, by the way, I have a question. Um, so you could say magnitude as like 5 feet and then direction as north. So 5 feet to the north is considered a vector.
Yeah, if I'm
Okay.
talking about position. So what you have said is a position, just like here. So this OA is representing the modulus, and this OA cap we call it. So direction is basically represented by cap. We call it
Okay.
cap. So this cap is something which is representing direction. We'll learn about what cap and modulus is and how we can calculate. But first we need to understand that how this thing is being represented. So suppose we have x-axis. So this x-axis is used or it is represented in vectors using I cap. The y-axis is represented using j cap. The z-axis is represented using k cap. We don't exactly write x, y, z. We simply said a vector is something which has certain direction, and those directions are represented by I, j, k cap. Let's move ahead. So this vector OA, this vector must have three components. We need to understand this.
Mm,
This vector must have three components, and those three components will be representing that how much this vector exists in, specifically x-axis, y-axis, and z-axis. So this is something which is represented by the coordinates itself. Like for example, OA vector can be represented by the difference between the coordinates of A and O. So what are the coordinates of O? It is going to be 0, comma 0, comma 0, because we know the coordinates of origin is 0, comma 0, comma 0. So if I'm representing OA vector, so it is something x minus 0 I cap plus y minus 0 j cap plus z minus 0 k cap. So here OA vector we got as x I cap plus y j cap plus z k cap. So this is given position vector of any particle. So this is how the position vector is being written, or you can say represented using different axes. Have you seen such things in class?
yeah. Yeah.
So basically, we need to understand that how these things came. If we are understanding that how they came, it will be easier to solve them. All right, let
Right.
me give you a very basic example once again, and you will try to tell me that what is going to be the given vector.
Okay.
So again, same, I'm assuming that initially a particle was at point A. You can consider it as an illustration. The coordinates of this point is -3, 2, 5. And particle was roaming here and there, and it went from this way to this and it reaches to point B. This point B has certain coordinates 4, comma 5, comma -2. So the question says, what is the displacement vector of this particle? So can you try and calculate it, that what displacement vector is going to be?
Yeah.
So first of all, we need to understand this fact that displacement vector should be represented by AB vector.
Right.
Like why we always write AB, or how this thing is actually written. A is something which is representing the initial position, and B is
Mm.
something which is representing the final position. So you can easily figure it out that at which position was particle initially and where it went finally. So just give
Okay.
me the answer directly that what AB vector is going to be.
7 I cap plus 3 J cap minus 7 K cap.
All right, absolutely correct.
Mm.
Minus 7 K cap.
Mm. And again, the caps represent the direction, and then the
Yeah,
numbers are well the position. So position, direction, which is vector, right?
exactly. So
Okay.
here, this is a vector, and this vector contains both directions as well as magnitude. Now let us try to calculate the direction and the magnitude separately. So as I told you, that magnitude is something which is given by modulus. Now how we are going to calculate modulus? Let us try to understand it. So AB vectors mod is represented by this way. Now understand this fact that whatever this particle has in x-axis, we'll square it. Whatever particle have in y-axis, we'll square it. Whatever particle having in z-axis, we'll square it and simply square root it. So what are we supposed to get here in terms of modulus or magnitude? So 7 square plus 3 square plus minus 7 square whole under root. So once we'll solve it, we'll get 49 plus 9 plus 49. So here AB vector's magnitude is going to be 98 plus 9, 107. That too under roots. So as it is a displacement vector, and displacement is something which has a unit, we use meters. So we'll be simply writing that it is going to be 107 meters. So this is how you are supposed to find the magnitude of any given vector.
Okay. And the standard unit is always meters.
Yeah. For displacement or for distance, the standard unit is always meters. So this is
Okay.
how we are supposed to solve it.
All right.
Now, the most important part is direction, that how we are actually going to represent the direction. So as I told you, the direction is something which is represented by cap.
Yeah.
So if you look at this particular relation once again, so can I say that OA cap is something which is OA vector divided by OA vector's magnitude? Can I say that?
Mm, yeah.
Yes, I can say that. So this OA cap is going to represent the direction here. And if we apply the same in this particular question, so let me write the answer directly. Look at it here. So I
Mm,
can say OA, not OA here. I should write AP. So here I would say AB cap is going to be AB vector divided by vector's magnitude. So the answer is the direction is going to be AB cap, which is equals to, just write the vector as it is, whatever vector we have got here, which we have solved it, and simply divide it by its magnitude. So we'll say it should be 7 by 107 I cap plus 3 by 107 J cap minus 7 by again 107 K cap. So this is how the direction of any given vector is calculated. Now,
That's,
this all x, y, z is representing, or I, j, k is representing that what is the direction of particle with respect to the origin always. Remember this. Whenever we are calculating direction, we are calculating direction with some reference. And when we are writing this in these ways, so reference is always origin. I mean to say is, suppose the particle has moved from point A to point B this way. So there must be some Cartesian plane. This Cartesian plane must have x, y, and z axis with the reference of origin. I'm writing these directions. That is what we need to understand. That we are writing
mm,
it with the reference of the origin always. This is the basic representation, or you can say that how the vectors can be actually solved or represented. We have seen this, but this is not something which is like only vector is limited to. There are a lot of other aspects as well. Let's talk about that. We were talking about the difference between scalars and vectors, and the basic difference there we have is that scalars can be resolved using basic mathematical operations, but vectors cannot. Another important point. So in order to solve vectors, we have different mathematical operations. We have different mathematical operations, or I would say laws. First, for addition, like in scalars, when we are solving scalars, we know 2 plus 3 is going to be 5. We know 3 plus 4 is going to be 7. This is this is how scalars can be added. But what about vectors? Vectors are built different. So if I say 3 plus 4, the vector is something which can lie between 1 to 7. Any number is possible. And how we are going to get this number? We are going to get this number. It will depend upon the angle between the vectors. Like whatever this sum is going to be, it will completely depend upon that what angle is there between these two vectors. We'll talk about it. So for addition, we have different laws. The first law is, you must have seen it, I guess, triangle law of vector addition. Have you seen it?
no, actually.
Then we have parallelogram law of vector addition. And apart from this, we'll be having polygon law of vector addition. So vectors are basically added using these three laws. This is not our general scalar quantity. So 3 plus 4 can be 1 sometimes, 3 plus 4 can be 7 sometimes, 3 plus 4 can be 5 sometimes. It will completely depend upon what is the angle between the vectors.
Okay.
So as I said, vectors are something which is represented using arrowhead. Like whatever vector we are writing, we'll simply draw arrowhead over it. So let us try to understand these things. But before, let us complete that basic operations. Similarly, for product of a multiplication, we also have different methods. Like generally, when we multiply for scalars, we simply say 2 times 2 is 4. But for multiplication, it can differ. So here are two different products we have which we use. And the name of these two products are dot product as well as cross product. So you must have seen this, as you told me initially.
Yeah.
Dot product
It,
and cross product are two different ways of multiplying two vectors, and we'll talk about them in detail
okay.
soon. Before that, let's understand what vectors exactly looks like and how we are exactly going to add them.
Mm-hmm.
So let me just give you an idea of addition of vectors. So first of all, suppose we have two vectors and they are placed in plane randomly. This is vector A, this is vector B, I assume. So
Okay.
vectors, again, a very important point about vector that you need to write also. Vectors are something which can be moved in the plane parallelly in any direction. This is very important. Like for example, if these are the two vectors and I want to move these two vectors, so I can move these two vectors randomly in any plane, like in leftwards, rightwards, upwards, downwards, anywhere, keeping their orientation unchanged. Now, what do I mean by orientation? Orientation means like if I assume these two vectors are making certain angle with x-axis, let's say. Orientation means this angle should not change. This is what orientation signifies.
Okay.
Like if I move these two vectors in the plane like that, so I want to join these two vectors. So suppose this is my x-axis and I'm joining these two vectors like that. This is A. See, I haven't changed the orientation. This is theta 1, I'm assuming. This is B. Again, I haven't changed the orientation. This is theta 2.
Okay.
So vectors can be moved in the plane parallelly in any direction, keeping their orientation unchanged. This is the most important point when it comes to solve vectors because we are using this point like in almost in every question. One
Okay.
more thing. So as I have seen that this is vector A. So this vector has two things in it. This head portion and this arrowhead is actually representing the head of the vector,
Mm-hmm.
whereas this portion is representing the tail of the vector.
Mm-hmm.
So the next point we have here is how do we actually see angle between two vectors? So whenever we are talking about angle between two vectors, we need to make sure either vectors are joined tail to tail or either vectors are joined head to head. This is the most important part. Because sometimes when we are solving a numerical, we'll be saying that the angle given in the question is representing angle between tail and head. So we have to formulate or we have to calculate the angle between either tail to tail or either head to head. That is an important part. So let's see how it looks like. So for example, suppose we have two vectors. One is A Another is B. It is drawn in such a way, in this way only. And the diagram says this is the angle 60 degrees. So let us understand it in a form of illustration only. The question says what is the angle between these two vectors? So what can you say about what is the angle between these two vectors?
60 degrees.
60 degrees. It is correct, but we have to actually, in order to see that what is the angle between the vectors, we actually have to move the vectors. That how we are going to move them. We either join them tail to tail or we either join them head to head. So let me do one thing. I shift this vector in the backward direction. So see what I am supposed to get. So this is going to be my vector A. Now this whole vector B, I am shifting in the backward direction.
Okay.
Can I draw it this way? So now
Yeah.
this angle is again remains 60. So no problem. This is one such way of drawing this particular figure.
All
Now
right.
another way of doing this. I will move this vector A in the forward direction. How am I supposed to do? Suppose so I'll keep the direction of B or the vector B the way it was initially. I'm moving this vector A in the forward direction.
Right.
So again, if you look at the angle between the vectors, it is going to be 60 degrees. So this is another way of representing the same, you can say, two directions or two of vectors. Angle between the vectors is going to be, we'll simply write angle between the vectors is 60 degrees.
And no matter this is because no matter the orientation of the vector, the angle will always stay the same.
Yeah,
Okay.
okay. Just try this out now and tell me what is going to be the answer.
Okay.
So suppose this is one vector A and this is another vector B. This angle is given as 105 degrees. What is the angle between the two vectors?
180 minus 105.
Hmm, correct. It is going to be 75 degrees.
Yeah.
All right. So this is now we're going to see a little tricky problem, but if you
Okay.
understood the concept well, you can do it. Look at
All
the
right.
screen. So here we have four vectors A, B, C, and D. We have given the following angles, I would say. This is 70 degrees. This is 110 degrees. This is also 70 degrees. And this is also 70 degrees. So the question is find angle between first A and B, second B and C, third C and D, and fourth D and A. So now try and tell me.
Okay.
You cannot answer it without redrawing the shape. So
Yeah.
try redrawing the vectors. Either join vectors by tail to tail or either join vectors by head to head in order to find the angle.
Right. Okay, for one I got 70.
For A and B, it's
Yeah.
70. Correct.
Two I got 70.
For B and C,
Yeah.
it is going to be 70. That's also correct.
Three I got 110. C and D.
Correct.
Four I got 110.
That is also correct. All right. So you learned it so well. That's fine.
Mm.
Now let's talk about that how we can actually add vectors. Because in order to add vectors, we need to understand that how the angle changes between the vectors. So next thing, or you can say this is going to be the last topic of today's class, addition of vectors. So there are two laws, triangle law and parallelogram law. And before actually talking about these two laws, I would say uh, let us try to understand how the vectors look like when we actually add them. So suppose we have two vectors and the angle between the two vectors is given by theta. This is A, this is B. The angle between them is theta. So whenever we are adding any of two vectors, we need to understand this thing that the sum of these two vectors must lie in between the vector and between the given two vectors. The triangle laws, or you can say any other law, would say when we are adding two vectors, when we are adding two vectors, their sum, or we also call it as resultant, or we also sometimes use it as net vector, lies in between the vectors, in between the given vectors. That is important. So this A and B, when we are adding them to the resultant, that is A vector plus B vector, must lie in between them. And this is something which I can write it as it is equals to R vector. Now let us
Okay.
try to redraw this particular diagram. Let us try to redraw this particular diagram. So I have, I'm assuming A vector was this, B vector was this, and the sum of these two vectors lies in between, like that. So if I redraw this particular diagram by shifting the vectors parallelly in the plane, I'll keep this A vector as it is. I'll shift this vector B towards this. And can I draw this AB like that?
Yes.
This is going to be the angle between the vectors. This theta is actually going to represent the angle between the vectors A and B. So, if you look at the diagram carefully, I'm be marking it as O, A, B, C. So, what type of triangle this ABC is?
Right triangle.
Right angle triangle. All right. So, this right angle triangle has one side given, that is AC as B. We don't have any idea about AB and BC. So, any idea how this AB and BC side can be found out?
Well, AB squared
Using
plus B
this, yeah,
equals,
using this vector and this angle theta. Okay, just tell me one more thing. Have you learned trigonometry previously in any other grade?
yeah, um, algebra 2 and pre-calculus.
Okay. So what sine theta is?
Sine theta is opposite by hypotenuse.
Hmm. All right.
Yeah,
So just
yeah.
try to look at it in the form of from right angle triangle perspective. Let us try to figure it out. All right, let's look at the diagram once again. Suppose this is my B, this is going to be my theta. So this is representing what side?
The hypotenuse.
This is representing
The first leg.
this one along with the
Yeah.
theta side.
Oh, 180. I mean,
What we call this side?
I just call it leg.
Like what?
A leg.
Okay.
Yeah, base
Yeah.
and leg.
Yeah. And similarly, we can call it third
Um,
side.
base and height.
This side, this side.
Mm,
We can call it opposite or perpendicular
oh,
because
we just
this,
call hypotenuse. The bases we call adjacent side and then opposite side.
yeah, this side is basically opposite to this theta. So that's why we call it either opposite or perpendicular.
Okay,
All
yeah.
right. So here we have B given and we need to figure it out that what this side is and this side is. So understand this thing. This B vector has two components. The one component is along x-axis, so we can call it Bx, and this component is along y-axis, we can call it By. So using trigonometry or using this right angle triangle ABC, I can say that, understand it this way only. If I want to find out the value of sine theta, what it is going to be?
Um, opposite by so yeah, opposite by hypotenuse. So B, yeah, by B.
So I can write it as B sine theta.
Yeah, you can.
Similarly, if I want to find out the value of cos theta, what can I write?
Was base by hypotenuse, which is bx by b.
So from here we get Bx as B cos theta.
Okay.
So what we need to understand here is that this By is B sine theta, whereas this AB is B cos theta. What we need to find? We need to find this value of R. So how can we find the value of R? In the triangle OBC, I'll apply the Pythagoras theorem. And when I am applying the Pythagoras theorem, I'll get the value of R. Look at it, how we are going to find it. So R square is going to be, it is something hypotenuse. Base square plus perpendicular square. We can write it this way. So what base is going to be? A plus B cos theta. Look at the diagram.
Yeah.
So I would say it is going to be A plus B cos theta whole square plus what is going to be the perpendicular? It is going to be B sine theta again
Okay.
square. So we'll solve this relation. What is A plus B whole square?
A squared plus 2ab cosine theta plus uh b squared cosine theta.
Yes. B square sine square theta.
Oh yeah.
So this is something which you're going to get when we open this whole square bracket. So A square plus B square. Can I take B square common from both the numbers?
Oh yeah, you can factor it out.
So I'll be getting A square plus B square cos square plus sine square plus 2ab cos theta.
Right.
Now, if you know what cos square theta plus sine square theta is, tell me.
Um well, cosine equals 1 by sine, right? Or
Yeah,
no?
that's a different thing, but
Okay.
sine square theta plus cos square theta is always 1. Remember this.
Oh yeah, I remember. 1.
So here the resultant is coming out to be a square plus b square plus 2ab cos theta. This is the most important formula we have seen here in physics. This is the relation which we are using like almost in every chapter. Not even a single
Okay.
chapter is here in which we are not using this formula. So what this formula is a square plus b square plus 2ab cos theta. What this theta is? This theta is the angle between the vectors, and we know that how we actually calculate or how we actually we see the angle between the vectors. So this resultant is actually representing the magnitude of the sum of two vectors. So when we are actually adding two vectors, it depends upon what this theta is. That's why I told you in the beginning that sum of 3 plus 4, if it is vector, it can be ranging anywhere from 1 to 7. It depends upon this angle because cos theta has different values for different angles. So do you remember what are the values of cos theta for different angles? What is cos 45? Tell me.
Cos 45, which is pi by 4. Uh, is it negative one? No. Is it 1/2?
It's 1 by root 2, not 1 half. So this is your
1 by.
homework.
Okay.
Learn all the values of at least sine theta and cos theta from 0 degrees to 360 degrees.
Yeah, you're talking about
Previously,
like
you
the
have
unit circle, right?
what?
Like the unit circle with unit circle.
Yeah, that's
Yeah,
what I'm
like that,
saying.
right? Okay.
So previously, you have done it till like, I guess 0 to 90 degrees, but here now you have to learn the values from 0 to 360 degrees. In the next class, I'll ask you some questions related to this only, and then we'll move ahead. And we'll be talking about the dot product and the cross product. So again, the process is very simple. Whatever we have learned so far in today's class, you need to make sure that you revise each and everything. And once you are revising these things, just do these questions once again. Once you are looking at these things and visualizing that how we are actually dealing with these things, it will be easier for you to remember because this is the very basic part. Whole physics is something which is based upon this only. So we need to make sure that we understand these things very well and we know how to apply them. Application part is again very important.
Okay.
Am I clear?
Yeah. Understand.
All right. So see you in the next class.